Next, let's go ahead and talk about horizontal shift. So if I have the graph f of x equals f of x minus h, this graph is going to have the same shape as f of x, but it's shifted h units along the x-axis. This one's a little trickier because we need to keep something straight. If I'm adding to it, that actually shifts it in the negative direction to the left. And if I'm subtracting from it, that actually shifts it in the positive direction to the right. So it's flipped. That's one thing to really keep in mind with horizontal shift. So if I have f of x is this, so if I have f of x equals the square root of x minus 2, let's go ahead and graph f of x is the square root of x. 0, 1, 4 is 2. It's going to have the same shape, but I know it's going to be shifted horizontally, and I'm telling you it's going to be shifted 2 to the left, to the right, right? It's shifted in the positive direction. Now, why does that work? Well, remember when we first talked about graphing radicals, I said you should set it equal to the first few perfect squares in order to find 3 points. So the first few perfect squares are 0, 1, and 4. So I have x is 2, x is 3, and x is 6. These are going to give me really nice values for my radicals. So if I take the square root of 2 minus 2, that's 0. If I have the square root of 3 minus 2, which is the square root of 1, that's 1. If I have the square root of 6 minus 2, which is the square root of 4, that's 2. So let's graph these ordered pairs. So I have when x is 2, let's graph it in orange because we like orange. When x is 2, y is 0. When x is 3, y is 1. And when x is 6, y is 2. So as you can see, everything has been shifted to the right. All the points been shifted to the right too. We should state the domain and range. I don't know that I did that on the last example, but we should always do that. So my domain goes from, which is all possible x values it can take on, goes from 2 included all the way to infinity. And my range still goes from 0 to positive infinity, because that's all my possible y values. When it's a vertical shift up or down, that's when our range is going to change away from 0. So in summary, if I add a constant, that's going to shift my graph in the positive or the negative direction. If I add a positive constant, my graph will be vertically shifted up. If I have a negative constant, my graph will be vertically shifted down. And then it's the opposites of what you think for horizontal shift. So if I add a constant, it's shifted to the left h units. And if I subtract a constant, it's shifted to the right, to the positive direction versus the negative h units. And you can always go into Desmos to graph these and check it out for yourself. This actually, I think, is an interactive. Let's take a look. Okay, so here's an interactive, right? So you can see here I've got this k constant. If I shift it positive, make my k like 6.6, it moves in positive direction. I can make it a negative 7.2, it would move in the negative direction. Let's try and put that back to 0. Okay, and if I have h, if I have a positive number, because it's minus h, that's a negative number, so it's minus. See that it's a minus here. 3.8 shift to the positive, negative direction, and so forth. So just kind of a fun tool, play around with, move your radical function around. So let's go ahead and bring everything together. I want us to describe the shift and state the domain and range. So let's look out here. This is my constant, so this is going to be shifted down 1, because this affects my vertical shift. And I add 4, which means instead of going in the positive direction, I go in the negative, so it's going to be to the left 4. So let's use this to find 3 points. I'm going to go ahead and graph the square root function. So here we go. This is f of x is the square root of x. And I said my graph was shifted to the left 4 and down 1. So I'm going to take every point and I'm going to go to the left 4. 1, 2, 3, 4, and then I'm going to go down 1. That's my new point. Left 4. 1, 2, 3, 4, down 1. Then I'm going to go left 4, 2, 3, 4, and down 1. So this is going to be my new graph that was shifted down 4 and left 1. So my points are when x is negative 4, y is negative 1, when x is negative 3, y is 0, and when x is 0, y is 1, because my graph was shifted down 4 and to the right 1. My domain, which is all x values it can take on, my domain goes from negative 4 all the way to positive infinity. And my range, which before went from 0 to infinity, now it goes from negative 1 included, right? Because this is when y is negative 1, all the way to positive infinity. Last thing I want us to take a look at the function f of x equals negative square root of x. Why don't I go ahead and graph our normal square root function, right? This is our function that pairs everything with the principal or the positive square root. You graph this enough, you'll get pretty quick at it. But if I have f of x as negative square root of x, this is going to map everything with its negative square root. So if I have x is 0, 1, and 4, square root of 0 is negative square root of 0 is still 0. Negative square root of 1 is a negative 1. And a negative square root of 4 is negative 2. So what this is this is my function. My new function is this. It's sort of reflected over the x-axis. And we're going to talk more about reflections of functions as we move forward through this course.